How's it going, everyone? Today, OpenAI released their first open weight models. This is a very big day. People have been waiting for this for a long time. So I just wanted to quickly kind of go over what they released, give some basic performance metrics, at least the claimed performance metrics from the paper, and maybe give a quick pointer onto how to actually run and play with these models. So what they released, OpenAI released two models, GPT OSS 120B and GPT OSS 20B. I'll put a link to the model card in the description. Basically, I like table 1 here. So these are a mixture of experts models. If you are watching this video, I'm assuming you know what a mixture of experts model is, but if you don't, it's in a normal transformer block. You have kind of two pieces, an attention piece, followed by a sort of feed-forward network, a classic MLP network. And mixture of experts, you have basically a little classifier here. This is kind of the picture. And instead of going into a single feed-forward network that's a deterministic path in each transformer block, you have a sort of chance that you can go into some number of different feed-forward networks. These are normally called experts. So generally, most of the weights in these transformer models are in these experts, and there's no difference here with the OpenAI models. It is kind of interesting just how so in MOE models you have active parameters and total parameters. These 120Bs and 20Bs are the total parameters, and the active parameters, so the actual number of parameters that any given token is going to hit in its path through the network. For the big model is only 5 billion parameters, and for the small model is only 3.6 billion parameters. So pretty sparse networks here. 36 layers for the big model, 24 layers for the small model. The attention architecture pieces seem to be identical, but the only difference is just the number of layers, and then the larger model has I think 128 experts per layer, and then the smaller model has 32 experts per layer. And yeah, here 128 and 32. So that's mostly it for the architecture. Other interesting things, maybe they are using grouped query attention, which is the same as Llama and Quen, but not the same as DeepSeek. DeepSeek uses something called multi-head latent attention, and yeah, they're using rope for the embeddings, and yarn to get a context window of about 132,000 tokens. And another kind of interesting thing is they ran training in FP4, this MX FP4 format. So that's basically 4 bits per weight, which means that this 120B model can actually fit on a single 80 gigabyte graphics card, which these are common if you're a professional, 80 gigabyte graphics cards. If you're a hobbyist or something, you're not going to fit on, you're not going to have an 80 gigabyte graphics card, but you certainly will have, could have a 12 gigabyte graphics card. So these smaller models are definitely, the smaller model is very focused on kind of consumer hobbyist, and then the bigger model is focused on kind of like maybe small company sort of thing. People who can afford these, professional class graphics cards. Another interesting thing here is they have this, what they're calling the Harmony chat format. So they actually released some code with this as well. Kind of an interesting new standard for how to format messages that go to the model. I know there's a bunch of competing standards right now. Sometimes people use this kind of like JSON format. So yeah, this is kind of interesting. Would be cool if people could rally around one of these things. Otherwise, yeah, tick token for the tokenizer, and 200,000 token dictionary. All right, so I think that's everything I wanted to cover with the kind of basics. As I mentioned, it's trained with a focus on reasoning, and code. So let's go into like the claimed performance here. So let's look at some of the benchmarks. For the main benchmarks, they are doing, there's this, I guess, figure 1 here, which shows you have, they put basically like competition math questions, and these are really, really popular like evals if you're looking at any of these kind of like frontier models. AIME is like, as it says, a competition math. GPQA is questions about sciences. MMLU also questions about sciences. They're multiple choice. And then HLE is another like kind of sciencey question. So interestingly, they generally are using tools. So the tools that they give these models are, I think they're listed a little bit lower here. Yeah, so browsing tool, which lets them browse the web, a Python tool, and what they're calling arbitrary developer functions. So basically, these models can browse the web and they can use Python. So answering especially like knowledge questions, like stuff in GPQA and MMLU, using the internet, definitely will help with that quite a lot. But they also are showing some no tool use benchmarks down later, which I'll also flash for you guys. But generally, I think the takeaways, at least the story that they're trying to sell, is that this model is basically in the O3 mini camp. So you see on AIME, it's the both models are basically like right above O3, and then on GPQA, the big model is pretty close, whereas the small model definitely gets some degradation there. It's kind of interesting to see that there's really not a whole lot of degradation between the big and small model, especially on the AIME. And then, the only benchmark that they show that shows like kind of a lot of gap here is this HLE benchmark. So this is kind of like knowledge-based questions. Shows, the models can do pretty good at knowledge-based questions. Especially when they have tools such as the internet. That's pretty reasonable. But then you have like kind of coding questions here. So Code Forces is kind of like LeetCode-ish style questions. SweBench is tickets from GitHub. So kind of more full like PR creation. And then TauBench is kind of like sort of benchmark that's focused on also tool use, but like kind of in a more like sandboxed setting. And again, here you see that the story that they're trying to show is that they basically have a model that's better than O3 Mini, and maybe at the level of O3 or slightly worse than O3. So coming down to the full evals, I guess another thing that's interesting to call out here is that they train these models with this like notion of high, medium, and low reasoning. So I guess when you query the model, you can sort of tell it whether you want it to be in low, medium, or high reasoning mode, and that will change how long the responses that you get from the model. So that's cool. And I guess this graph is showing that you're getting better at AIME. These are the math questions, and GPQA, the science questions when you are reasoning more. And then, I wanted to show table 3. That's this one here. Nope. That's this one here. So here they're again showing now basically like the full list of benchmarks here. I'll just leave this on the screen for a second so you guys check out. But basically, they show that they're actually doing quite well even without tool use on some of these knowledge-based benchmarks, which are, again, interesting. So, story they're trying to sell, O3 class models now in open source, and I think we're gonna have to see. So next thing I kind of wanted to talk about really quickly is sentiment. So generally, two places I look for this are Local Llama subreddit and Hacker News. And just checking the sentiment today, kind of hard to tell. I don't think a lot of people have really played with these models, especially the big ones. But generally, people making fun of the sort of like safety of these models, the fact that they won't lie to the user if the user asks them, and kind of there's always this trade-off between helpfulness and harmfulness. And seems like OpenAI maybe have gone a little bit on being too harmless. And yeah, different sentiment. I would love if people have used this, what they think about these models. I think I'm seeing some people say that they're great. I'm seeing some people say that they're crap, and that like Quen and the Chinese models are way better. So kind of hard to say. Obviously, OpenAI is capable of releasing a frontier class model. All they have to do is distill off of their big models. So yeah, seems pretty reasonable. Another kind of interesting thing that they released, which I like benchmark that they released or figure they released, is down here in figure 15, which is that so they're showing that internally they have, I guess, this benchmark they've built of their own PRs inside of OpenAI, and they're showing that like these models can clear 37% of their own internal PRs. So the idea being that like these models can do like a third of the work of a like OpenAI developer or something like that. So again, a big part of the story they're trying to sell with these press releases. Very, very hard to tell what's actually going on, but yeah, they're trying to sell this O3 class model, and I guess that's the big takeaway. So if you want to run these models, they have put the model weights on Hugging Face, easy to load models on Hugging Face. They also have VLLM and OLLAMA instructions. OLLAMA super duper easy to use, as well as LM Studio. So yeah, if you have the resources, definitely go and check out these models. And yeah, let me know how they are going for you in the comments. And if you like this style of kind of like quick news video. All right, I hope everyone has a great day, and I'll see you around.